Well, this is the situation given, right? According to diagram, we can relate it like this: north, south, east, west, right? So that means based on this directional information of north, south, east, west, we can say that A is located initially due 20 meter north of B. Yes or no? Jivita? A is located initially due 20 meter north of B, right? So as per the given velocities suggested for A and B, B is running towards A and A, that is due north, and A is running due east. So my question is, first part of the question is, what will be the minimum distance of separation? What is the minimum distance of separation between A and B? First calculate this. What will be the minimum distance of separation between A and B? We can do it in two ways. One is the idea of solving of this is the using absolute frame. Another one is the relative frame. Okay. In relative frame, it is comparatively easy. See, I am showing you how to solve this. I will solve it using relative frame. Using relative frame. So as per the use of relative frame is concerned, right, what we are supposed to do out of these two given moving bodies A and B, suppose any one, either A or B, you can make one of them. Relative frame means when the things are observed from a moving observer. When we explain the physics based on the moving observer, so then the discussion is said to be a relative frame. So out of these two moving bodies, if I taking B as an observer, taking B as an observer, right? So obviously, whenever a moving observer will be used to explain the observation about the other bodies, so a moving observer is apparently at rest. During the observation, a moving observer apparently remains at rest. Okay? So if I'm taking B as the observer in this case, so I need to take B as the moving observer. So state of motion of B during the observation will be static. So this implies that static B, though practically it is moving, but with respect to relative frame, static B will observe, right? Static B will observe the motion of A, as per the velocity of VAB, right? B cannot see the real motion of A. Any moving observer cannot see the real motion of other moving bodies in its surroundings. So that's why one moving body can always see the relative motion of other moving bodies. So like in the same concept, B cannot see the real motion of A, rather it can see the relative velocity of A, which is VAB. So therefore, we can reach to the conclusion of the relative velocity vector VAB, which can be obtained by the vector difference of A and B, that is VA minus VB, right? We know the status here about A and B. A is going due east with the speed of V1, B is going with the speed of V2, that is due north, right? That velocity 2, this velocity is 4. So whenever we try to know the relative one, we can convert the subtraction into addition by doing this rearrangement. Yes or no? So that means it can be shown as the relative vector is nothing but the addition of positive direction of motion of VA with the negative direction of motion of VB. So that means it can be shown, this can be written as the minus VB. Are you getting it or not? So taking the rectangular form, so this diagonal will represent VAB. So here the VAB vector will be this one. This one will be the VAB vector. Are you getting me or not? So that means with respect to the initial separation between A and B, from B, when B is taken as an observer which is apparently at rest, it can see the motion of A along the line of this using the velocity of VAB. Are you getting me? It cannot see the real motion of A which is actually going due east. Got it? So therefore, we can calculate this magnitude of the relative velocity VAB, right? So this VAB can be written under root of V1 square plus V2 square. So V1, I think I have given 4 and V2 is 2. So it will be under root of 16 plus 4. So that is root 20. Root 20 means it is 2 root 5. It is 2 root 5 meter per second is the relative velocity. So about this 2 root 5 meter per second velocity is observed or measured by B. So according to B, when A will travel along this line using this velocity, there will be a position called C. If I name the foot of the perpendicular C, so when, as per B, when A will move along this line using this velocity, when it will reach the point C, that time B to C will be the closest distance of separation between moving A and apparently static B. Are you getting me or not? Between moving A and apparently static B, this numerical measurement of the side of this right angle triangle geometry in ACB, the length of BC, are you getting me? The length of BC will represent, BC is equal to the minimum distance between apparently, according to the, I'm using that language what I've used here in solving problem, minimum distance between apparently static B and moving A, right? Or this is equal to the closest distance of separation, right? So using this right angle triangle, if you consider this angle theta, then this side BC, which has been marked as C, so that can be straightway written, it is AB into sine of theta. So AB is D sine theta. So D is the initial separation, I think that was given 20 meter, right? And now for sine theta, this theta is equal to this, where I know the magnitude of VB is 2, magnitude of VAB I have got 2 root 5, and magnitude of VA we know it is 4, right? So can we calculate from this geometry, can we calculate sine theta? So yes, from geometry sine theta can be written perpendicular to hypotenuse, so it is 2 divided by 2 root 5, means the numerical value of sine theta is coming 1 by root 5. So if I use this value 1 by root 5, D was given 20, sine theta is 1 by root 5. So 20 by root 5 means it is 4 root 5 meter is the least distance of separation between A and B. So far as the observation is concerned, what did we do in the first part of calculation? B was apparently at rest. That this was the position of A to B. It was a 20 meter separation, right? The particle, the object or man A, that was moving along this path using the velocity 2 root 5, right? This was the theta, and I said that when if you drop a perpendicular from the apparently static observer at B on the path of moving A as it is seen by the observer, so then the time taken by this motion, the time taken by this relative velocity to travel through A to C will be the time spent to come closest with respect to B. That means we can write down time taken to reach closest, will be equal to time taken to travel through AC using velocity of VAB, right? So this required time calculation will be displacement AC by velocity along that path, which is V relative. So AC will be, according to this geometry, AC will be d cos theta, right? So AC lengthwise will be d cos theta, that divided by VAB. So likewise the previous calculation of the right angle triangle geometry, as I got the value of sine theta Oh, ho, ho, ho. I made a mistake over there. I made a mistake. VAB, I have done sine theta is this by this. This side was 4, not 2. Make a little correction. This was 4 by 2 root 5. So numerical value of sine theta was 2 root 5 and cos theta will be 1 by root 5. I made a, I thought I wrote down this part here, so I thought this is the velocity I'm using. No, no, no. That was 4 and base was 2, right? So we need to make a little bit of correction here. So this sine theta was 2 root 5. So that means, oh, sorry, it is 20 into 2 root 5 means 40 by root 5. So it will be 8 root 5, right? Instead of 4 root 5, it will be 8 root 5 was the least distance. And calculation of time taken, that one will be d cos theta. So d was 20, cos theta is 1 by root 5. That divided by the velocity, which was 2 root 5, right? So with this we can write down 10 by, okay, 5. So this is 2 second, correct. 2 second is coming the time taken to reach the closest. Is that clear?